Good morning, dear students of class 10 Patanjali Rishikul. Today we are going to discuss about a topic, force on a current carrying conductor. This experiment was supported by Ampere. He said, if a current carrying conductor produced a magnetic field and exerts a force on a magnet, then a magnet should also exert a force on a current carrying conductor. For this, he performed a small experiment which can be seen as follows. Here, the small experiment about force on a current carrying conductor. We take a small aluminum rod, which is of about 5 centimeter. This can be seen over here. This PQ is a small aluminum rod. Before this experiment, it will be freely suspended vertically like this. Okay. Now, using the two connecting wires, one connecting wire that goes like this and the other one from this direction, that is Q. So we take two connecting wires which is suspended from the stand. Here you can see the wires are suspended from the stand. We place a strong horseshoe magnet in such a way that it lies between the poles within the magnetic field that is upward as shown here. So this rod will be placed between the poles of the magnet. Now, connect the aluminum rod with the battery. The aluminum rod, as you can see, is connected with the battery over here, right? So now, as soon as the switch is closed, the current will be induced in the circuit. On passing current, you will observe that the rod displaces toward the left. As you can see over here, the rod is being displaced towards the left. Okay, initially it was vertically like this. Now it has been displaced towards the left. Okay, so this is being done because of the current induced in the circuit. One more thing is observed, if the direction of the current is changed, this rod will displace outside, that means towards the right. So from this we can conclude, if the direction of the current is changed, the force that is being exerted also changes its direction. So that means they are related to each other. So performing this experiment number of times, it was observed that the force exerted is maximum only and only when the conductor is placed perpendicular to the magnetic field. When the conductor is placed perpendicular to the magnetic field, then the force exerted was maximum. So from here, this can be derived by Fleming's left hand rule. So you can see this. According to this rule, if we stretch a forefinger, a middle finger of your left hand in such a way and thumb in such a way that they are mutually perpendicular to each other. So you will see it should be something like this. One thumb, this is your forefinger and this is your middle finger. All three are perpendicular to each other. So here the first finger, that is your forefinger, that gives you the direction of the magnetic field. So this is your direction of the magnetic field. Then your middle finger tells you the direction of the current. So here you can see the direction of the current is outside. Then your thumb will indicate the direction of the force. The thumb will indicate the direction of motion of the force exerted on the conductor. So here you can see the direction of the force is upward. So this is your Fleming's left hand rule through which we can find out the direction of the force being exerted. So today we have discussed about force on a current carrying conductor. That means when a conductor is being placed in between the poles of the magnet, then the magnet will exert the force on a conductor also, and the conductor will keeps on moving. When the current in the circuit is induced, only and only then this is possible. If there is no current in the circuit, then your rod will be freely suspended. That is in vertical position. So as soon as the current is passed again it will start moving depending on the direction of the current. If the direction of the current is on the from the positive, that is towards the left, it will go left. Depends on the experiment setup that we use. So with this, we have seen that yes, the magnetic field, the magnet also exerts the force on a current carrying conductor. I hope you all have understood this topic. Thank you and have a nice day.